Cats, I hope you can take a moment in your evening and learn some math here. Let's get busy. This is one of the most difficult videos. We're going to do difference of two squares, perfect square trinomial, and then we're going to factor completely. All right, starting with difference of two squares, I would suggest that you pause this for a moment, try to do these two, and then come back and work them with me. Number one, we have two terms. 49 and 25 have nothing in common, so I'm not going to be able to factor anything out. I'm going to do two parentheses. If it's difference of two squares, there are two terms. We're going to have two different signs, and then now we have to fill in the blanks. 49 will be 7 times 7. We're going to take the x to the 12th and put half of them at the front, 6, and half of them at the back. Then I'm going to take the 25, it'll be 5 times 5, and then y to the 16th is going to be y to the 8th. Since it's an exponent, you always take half of it. All right, let's try number 2. It's a difference of two squares, so I'm going to do my two parentheses, one's plus, one's minus. 3p squared is 3p times 3p. And then I need to do the 225, which is just 15 times 15. Whoops, hold on. We have a problem here, and I just want to talk to you about this while we are here. Okay, this problem is incorrect, and the reason I know this is because 3 goes into 15. So I'm going to start over again, because what's the first thing I always told you to do? You always do GCF first, and Miss Winship lets you guys down, and I didn't do that. So I'm going to look at 9 and 225. The common factor between these two is 9, and that gives me p squared minus 9 times 25 is 225. Then I take the 9, leave it out front, and do p plus 5 and p minus 5. All right, sorry for that mistake, but I am glad that I caught that to show you how you can fix yourself. So anytime you have two numbers with the common factor, you need to start over again. All right, the next thing we're going to do is perfect square trinomial. This is a trinomial, and the answer to the trinomial is going to be a parentheses squared. These are our double stuffed Oreos. To get the 9x squared, I'm going to put in 3x, because 3x squared is 9x squared. To get the 400, I'm going to put in minus 20. By the way, on this one, before I started, I did check everything to make sure nothing could be taken out. All right, now we're going to check for the 120. 3 times 20 is 60. Then you have to double that. That gives me 120, so my answer is correct. Number 4. I don't know of anything that goes into all of these numbers. Nope. Okay, so I know this is a perfect square trinomial because the 81 is squared and the 289 is actually 17 squared. So for the first term, I'm going to have 9z plus, my second term is going to be 17, and square it. Okay, to check myself, 9 times 17 is 153. If I double that, that gives me 306, so I am correct. Number 5. Okay, this is the new part for today. This is called factor completely. Not only are you going to have one step or two steps, sometimes you're actually going to have 3 steps when you're trying to solve this. All right, so the first step I always try is GCF. When I do GCF, I look, they all have a 2 in common, so the first thing I'm going to do is factor out a 2. That leaves me with 2 and then x squared plus 21x minus 54. Okay, so now I need to multiply to get 54 and add to get 21. You can make a chart to decide, because I really don't know it off the top of my head. That would be 2 times 27, but that doesn't give me 21. 3 times 18, and guess what? That does give me 21. I'm going to bring down the 2, and then I'm going to fill in x plus 3 and x plus 18. That is my final answer. All right, number 6. I notice that it has 4 terms. Since it has 4 terms, it's going to be grouping. But the first thing I need to try is GCF. So GCF for every single one of these. But there's nothing that goes into everything. So I'm going to divide and conquer. And I'm going to find a greatest common factor between 4m to the 4th and 16m squared. I think they both have a 4 in common. They also have an m squared. In the parentheses, that leaves me with m squared minus 4. Let's go to the second one. That's going to be plus 25 goes into both of these, and then I'm left with 4 minus m squared. Now, I don't know if you remember from the video from the other night, but if I have 2 parentheses and I need to turn one of them around, I can just rewrite it. 4m squared minus 4 minus 25, and that turns it around to m squared minus 4. Now I'm going to do my common factor. I have m squared minus 4, and what's left over after you take those out is 4m squared minus 25. Okay, I had to rewrite this to give myself a little bit of space. Now, we've done greatest common factor, we've done our grouping, but look inside right here. These are another difference of 2 squares. So I'm going to take this part and change it to m plus 2, m minus 2. And then I can take this, which is also another difference of 2 squares, and do 2m plus 5 and 2m minus 5. So what I'm saying to you is, if you see a square, you need to keep going one more step. All right, this would be the final answer. Do you see how there's 4 terms here? 1, 2, 3, 4 in the parentheses. And look right here. We have m to the 4th power. Interesting, huh? All right, now we're going to try number 7. I'm going to go pretty quickly, so pause if you need to. The first thing I'm going to try is GCF. They all have an x in common. They also all have a 2 in common. So I'm going to bring out a 2x. Left inside the parentheses is going to be 6x squared plus 5x plus 1. You do have to have the 1 there. My next type of factoring, I notice that it's a trinomial, and actually it's going to be a slip and slide problem. I'm going to take the 2x, bring it down, 6, slip it to the end, so I get x squared plus 5x plus 6. Now I need to factor that. 2x, x plus 3, and x plus 2. Now I need to slide the 6 back under, and I'm going to leave the 2x in front. Oh, looky here. 3, 6 gives me x plus 1/2. Put the 2 in front. That gives me 2x plus 1. This x plus 2/6 is x plus 1/3, and that is 3x plus 1. That is my final answer. Number 8. On number 8, I'm going to begin with greatest common factor. I do notice that there are only 2 terms, so I'm thinking that difference of 2 squares is going to happen in just a minute. They both have an x in common, so I'm going to factor out an x. That leaves me with x to the 4th minus 81. Now I look inside and I see that that is the difference of 2 squares. I need to take half of the x's and put them at the front. One's a plus, one's a minus. 81 is 9 times 9. Now I need to go again. This is difference of 2 squares. It's a DOS, difference of squares. Now, this is not difference of squares because it's a plus. So I'm going to drop down my x and drop down my x plus 9. This is a difference of 2 squares, so I need to change it to x plus 3 and x minus 3. Check it again. I have this squared, but it's a plus sign, so it's done. X plus 3, guess what? We are done. Number 9. I see 4 terms. I'm thinking that it's going to be some type of grouping. There's nothing in common, so I'm going to divide and conquer. I'm going to start with taking out a 9m squared. Inside, I have left 4m plus 1. Okay, and the second part, I have a negative in front. And remember I said if there's ever a negative, take it out in the front. And inside I have positive 4m plus 1. I have 2 4m plus 1s. I'm going to bring that in front. 4m plus 1. Cross them off. Look and see what you have left inside. 9m squared minus, well, there would be a 1 there, so I'm going to put a 1. Now this 4m plus 1 is to the first power, so I know that part is complete. 4m plus 1. This squared right here, I do have to try to keep going. It's another difference of 2 squares, so I've got to take these and break it into 2 parentheses. What's left over is going to be 2 sets of parentheses. 3m plus 1 and 3m minus 1. Go ahead and write down number 10, and we're going to check it when you get to class tomorrow. All right, have a great evening. Sorry this video was so late, but Miss Winship had things to do. All right, have a good night. Bye-bye.